Welcome back. Now, I think I left you in the last video with just a slight problem, and I had to make a few changes to the script here. I think the biggest thing was I've divided it by 2.5f and making sure that this is less than and then greater than over here, and then less than and greater than there, so that they match up. I was finding that the ball widths, for some reason, dividing it by 2, it would seem to be too big. So I found that by just increasing this a little bit, so therefore decreasing that ball width, basically, dividing it by a larger number, seemed to work out okay. So if I go back and look at this now, hopefully the ball will appear, and it should bounce back and forth with no problem. And so now it's bouncing back and forth. The movement looks pretty good. If I move it down, it works as well, right? So, and then if I miss it, it goes flying off. Now, obviously, that wouldn't be too fun of a game, right? Just leave the paddle there forever, and you know, not much of a game there. So what we need to do is get it to bounce in a bit of an angle. And the idea with Pong is that if it came in straight and hit sort of the middle, it would basically bounce straight back. But if it sort of comes off to the side, okay, if it hits closer to the edge, it's going to bound off at a different angle there. And so we're going to do this by doing some programming. And one of the things we have to concern ourselves with is the use of radians. Some of you never probably heard of radians. Some of you have dealt with radians. This is not a math class, so I don't expect you to, have to study radians here. But it's one of those examples where you might say, well, where am I ever going to use this in math class? And well, in computers and even video game design, you're going to run into it because in the end, a lot of this is physics, a lot of this is math. The whole basis of a computer really is math, and so it's gonna come up to. So just a couple little things about radians and degrees. They have, we know in a circle there's 360 degrees. You can also sort of divide up the circle into radians, and basically one complete circle 360 degrees is the equivalent of 2 pi. And so you can go between radians and degrees quite easily. And you can see here, if you've got the radians in R here, you multiply by 180 degrees and divide by pi. And then just conversely, if you've got the degrees and you want radians, you times it by pi and divide it by 180. Our brains, we're sort of used to using degrees, so sometimes it's easier to work in degrees and then convert to radians, and that's kind of what we'll be doing here, because it just gives us a bit of an idea. Some of you who've been doing more math, you might even be able to think purely in radians, and you could just sort of work completely in radians here. But we'll use degrees and then just have a conversion to radians here. All right, so like I said, we have to be able to figure out how this ball is going to bounce. So I'm going to go back into my script here, and what we're going to want to do is create a few variables. So I'm going to go back up to the top here. So right under game object, we declared our paddle player and paddle computer. What I'm going to do is just put in another private float, and we're going to call this bounce angle. And we're basically going to calculate this bounce angle here. We're also going to create another float. This one, there's two of them actually, Vx and Vy. And we'll get this into a second, but it's basically the position of our x, like on the x and y coordinate. It's going to be a coordinate position that we're going to sort of bounce the ball towards, and that's going to be getting the ball to move in sort of that direction. And then we're going to create a float, a float, but a maximum angle that we're going to be able to bounce the ball at. One of the things we have to make sure as it gets really close to the edge is that we don't get it to bounce straight up or down. So we'll limit it to 45 degrees as our maximum angle. So if you can imagine coming in, it would bounce off at 45. We can play around with that if we need to, but I think that should work pretty good. All right, so what we're going to do sort of next here is get some sort of calculation here right at the start, sort of generate our random bounce so it doesn't always bounce straight ahead at the beginning of the game. And so to do that, I'm just going to come into here. Let me just clean this up a little bit. Yours might not be that. I was doing some debugging earlier. And so we're going to declare a bounce angle. And what we need to do is basically get sort of a random bounce value, okay? And to do that, so I said this is going to be our get random bounce angle. Now, we don't have a function called get random bounce angle, so we're going to have to make this. So basically, at the start of the game, like I said, we want to have a angle that the ball is going to shoot at, and we're going to make it random. Okay, so let's go define this function here. So I'm just going to go down. Now that bounce angle, just under the move here, so it's going to have to return a value, and that value is going to be a float. So we have to get a number coming out of here. So we'll call it our get random bounce angle, just like we did before. And we're going to do something a little bit different here. We're going to put in two values. We're going to put in a float called the min degrees. And we're actually going to set that value. So I'm going to set it to 160 degrees, basically. And then another one, which is going to be our max degrees. And that's going to be 260. So don't worry too much about these at the moment. Mathematically, they sort of work out here. So let's just close that up. So what we have to do is randomly choose a value between 160 and 260F. And so but we need this to come out as a radian. So what I'm going to do is, just like we were talking about with that math there, I'm going to put in the float min rad. Okay, so the minimum radians is going to equal basically the min degrees. Min degrees, there we go. And it's equal to, or sorry, times the math. So we're going to grab a math function dot pi. So that's just being able to put in 3.14, and then we're going to divide that by 180. Okay, so that's just the same math that we did before. And then the float max rad, so the maximum radians we can get is going to be the, max degrees. Same math here, degrees times the mathf function again, dot pi, so basically times pi divided by 180. If I can type here, okay, good. So we've got 180 degrees, we're taking the degrees and converting them into radians. So we've got to return basically a value here. So we're going to return a random range. Return random. So this is going to create a value, range, and that value is going to be somewhere between the min rad and the max rad. Okay, so basically somewhere between 160 and 260F, those are going to be converted into radians. And then that value, whatever it is, those two values are going to be used as the min and max point in this random, right? So it's going to generate a random number between those two values. And since it's returning it, that's what's going to come up over here. So once that function is run, right? So that was called, where did we call it? Right here. There we go. So bounce angle. So it's going to call that function. That function will generate that value. And then that's what's going to come in here. So bounce angle will be some value between 160 degrees and 260 degrees. And just to show you the benefit of doing this, if I put this in again, just to sort of show, you can see that it tells you that we've got our min and our max, and we've set them to 160 and 260. But if you really wanted to, you could just put in two different numbers here to change the min and max values. So it sort of has default values, but those are changeable as well. But we'll just go with the default ones at the moment. And the other thing we have to do is calculate the sort of the position on that Vx and that Vy. So I'm just going to just sort of start this off here. Just do that. So this really here is sort of going to be the position on the x-axis and the position on the y-axis. Now I'm going to put the math in here. We're going to times the move speed by the math function, so back to mathf, and we're going to use the cos, okay? And we're going to pass in that bounce angle. So the cos of the bounce angle, that will get our x position, and I'll explain that in a second with the little diagram. And then the other one, move speed times negative mathf, and this is because it's a sine. Again, I'm not going to get into the math of this, but it does make sense, of the bounce angle as well. So this will give us basically our x position, and this will give us a y position. And so how that works, let me just pull over this diagram here. Okay. The idea here, right, your cos and your sine of this angle will give you your x position and your y. Because if you sort of draw a little line down here, this is the hypotenuse, right? Cos we know is adjacent divided by hypotenuse, so this is the adjacent here, and that's sort of along our x-axis. Whereas the sine, right, is the opposite, and the opposite would be your vertical line here, and so that would position it vertically along the y-axis. So that is why, if we go back here, we've used sine for the y, the vertical, and cos for the horizontal there. All right, so we've got that. I think we'll end this video here. We actually haven't really done anything, but we've set sort of the groundwork here. And in the next video, we'll get the ball bouncing at an angle.